Hello, in this video we will be drawing a 45 degrees right triangle and evaluating trigonometric functions of 45 degrees. If you sketch a right triangle, let's say our 90 degrees is here, we want to work with 45 degrees, so let's label this corner 45 degrees. This leaves us with 180 degrees, that is the sum of all angles in a triangle, minus right angle of 90 degrees here, which gives us 90 degrees, minus the 45 degrees that we labeled one angle, which leaves us with 45 degrees for the third angle of this triangle, so 45 here as well. Two congruent angles in a triangle creates isosceles triangle. What isosceles triangle means for us is that if we label this leg of the triangle 1, then the other leg will also be equal to 1. At this point, we just need to calculate hypotenuse of this triangle, and in order to do so, we will use Pythagorean Theorem, which is c squared equals to a squared plus b squared. In this triangle, we do not know what the hypotenuse is, so we leave c as is. C squared is equal to, one leg is equal to 1 squared, plus the other side is also 1, and we need to square it. So c squared is equal to 1 squared is 1 plus 1 squared is 1. We have c squared is equal to 2. A square will cancel out with a square root. We need to do the same to the other side. So we square root on both sides and get that hypotenuse c is equal to square root of 2. So radical 2 for the hypotenuse. Now that we have labeled all of the angles and sides, we can proceed with evaluating trigonometric functions of 45 degrees. In an isosceles 45 degrees right triangle, it doesn't matter which 45 degrees you're working with. I'm going to label this as our angle theta. So sine of 45 degrees is equal to, we set up a ratio of opposite side from 45 degrees, which is 1, out of the measure of the hypotenuse, which was radical 2. We still need to rationalize this ratio, but before I proceed, I'm going to calculate cosecant of 45 degrees because it's the reciprocal of sine of 45 degrees. In this case, it would be radical 2 out of 1, which would just simplify into square root of 2. We need to rationalize ratio of sine of 45 degrees, which is 1 out of radical 2. Square root would cancel out with a square, so if we have another factor of square root of 2, that would create a square in the denominator. So what we do in denominator, we have to multiply the same thing into numerator, so 1 times radical 2 as well. This creates 1 times radical 2 in numerator, out of square root of 2 times square root of 2, that's a square root of 2 to the second power. Square and a square root would cancel out, and we get sine of 45 degrees is equal to square root of 2 out of 2. So we have sine of 45 degrees is radical 2 out of 2. Cosecant of 45 degrees is square root of 2. Let's proceed to calculate cosine of 45 degrees. And cosine is the ratio of adjacent side. So adjacent side in this triangle will be 1 out of hypotenuse square root of 2. Once you have a cosine of 45 degrees, you also have a secant of 45 degrees, which is a reciprocal of 1 out of radical 2, which is just radical 2 out of 1. Notice that in an isosceles triangle, sine and cosine of 45 degrees have the same ratio. We still need to rationalize cosine of 45 degrees by multiplying numerator and denominator by square root of 2. which will simplify cosine of 45 degrees equal to radical 2 out of 2. So this is our cosine. Secant of 45 degrees is square root of 2 out of 1, which is also radical 2. Secant is congruent to cosecant. Tangent of 45 degrees is the ratio of opposite side from 45 degrees, which is 1, divided by adjacent side, which is also 1. Once you have tangent, you also have cotangent of 45 degrees, which is also a ratio of 1 out of 1. So both tangent of 45 degrees simplifies into 1 and cotangent of 45 degrees is also equal to 1. That's all.